Welcome to today's topic, module for polymer chemistry. What do you mean by polymers? Polymers are macromolecules formed by repeated linkage of large number of small units. That small unit is known as monomers, and monomers combines to form a bigger or macromolecule, and that process is known as polymerization. Polymers are classified by origin. They are classified into natural and synthetic polymers. By the properties, they are classified in elastomers, plastic, and fibers. And nature of monomers, they are classified into homopolymer and copolymer. What do you mean by homopolymer and copolymer? In homopolymer, there is only one type of monomeric unit is present in polymers, and that type of polymer is known as homopolymer. For example, polyethylene. So repeating unit is ethylene, and here only one type of monomeric unit, and that is an example for homopolymer. Another type is copolymer. If more than one type of monomer is present in a molecule or in a polymer, and that type of polymers are known as copolymers. The copolymer, based on the arrangement of monomeric unit, the copolymer is further classified into alternating copolymer, random copolymer, and block copolymer. Alternating copolymer, the polymer monomers are arranged in such a sequence A, B, A, B, A, B, and that type of copolymers are known as alternating copolymer. And random copolymer, there is no such sequence of arrangement A, B, 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 A, A. That type of copolymers are known as random copolymer. And Bloco Polymer is a type in which the first is a block of one monomer, and next is another block of next monomer, and that type of polymers are known as Bloco Polymer. That is the main classification of polymers: homopolymer and copolymer. Polymers are formed from the monomer, and that process is known as polymerization. There are two types of polymerization: addition polymerization and condensation polymerization. What do you mean by addition polymerization? If a monomer is added together to form a bigger molecule or macromolecule, and that type of process is known as addition polymer. Addition polymerization is otherwise known as chain polymerization. Here, as an example, ethylene, if undergo polymerization, we get polyethylene. Here the repeating unit is C2H4. Is the repeating unit. See, consider C2H4 is a ring. In this one is added to the next C2H4 molecule, next C2H4 molecule. Like a chain, its process continues. We get a longer or macro molecule, and that is known as chain polymerization. And there are two types. Addition polymerization is classic. There are two types: one to addition and one for addition. Two types: addition polymerization and condensation polymerization. What do you mean by addition polymerization? The reaction of monomers without the elimination of atoms, we get a polymer. For example, ethylene undergo polymerization, we get polyethylene. Here, this ethylene molecule, that is C2H4, undergo reaction, we get a polyethylene molecule. Here, C2H4, C2H4, C2H4. There is no elimination of atoms in this type of polymerization, and that's why this one is known as addition. The monomers simply adds together to form a macromolecule or polymers. Next is condensation polymerization. Polymers formed by a condensation reaction. What do you mean by condensation reaction? The reaction with the elimination of more molecules like water, HCl, ammonia, etc. And that type of reaction is known as condensation reaction. And polymers formed by condensation reaction or with the elimination of more molecules like water, and that type of polymerization is known as condensation polymerization. Here is an example when this dye is in OH and this one is COH, it undergo polymerization to form a polymer with the elimination of small molecules like water, and that type of polymerization is known as condensation polymerization. Then addition polymerization is further classified into two: 1,2 addition and 1,4 addition. 1,2 addition means this one is ethylene. Is take ethylene example for ethylene. Ethylene undergo polymerization for polyethylene. Here this double bond breaks. Here this carbon is active. This carbon is active. Next monomer is adds in the first carbon, next in the second carbon. So like okay, manner, the polymerization continues, and that type of polymerization is known as 1,2 addition. Next is 1,4 addition. Here 1,3 butadiene. Buta means for 1,3 butadiene. Undergo polymerization, we get polybutadiene. Here this is double bond is an active site. This double bond, another active site. Break this first carbon is active. Then this form a double bond here, and fourth carbon is active. Next monomer is on in the first and fourth position, and like this first and fourth position. That way we get a polymer, and that type of addition polymerization is known as 1,4 addition. It's the two classification of addition polymerization: 1,2 addition and 1,4 addition. For 1,2 addition example, formation of polyethylene from ethylene. 1,4 addition, formation of polybutadiene from butadiene. Condensation, your familiar example is nylon 6,6. When adipic acid undergo adipic acid and hexamethylene diamine undergo polymerization, we get a polymer that is known as nylon 6,6. That is 6 stands for 6 number of carbon acid. Hexadienoic acid, that is adipic acid. Hexamethylene diamine undergo polymerization, we get nylon 6,6. That is another example for condensation polymerization. Let's say two types of polymerization: addition polymerization and condensation polymerization. Main difference between this addition polymerization and condensation polymerization is monomers must have either double bond or triple bond. In addition polymerization, monomer must have two similar or different functional groups. That is in condensation polymer. Then only the elimination of small molecules like water, ammonia, etc. takes place. Produces no byproduct. That is, monomer simply adds to get a polymer. That is in the addition polymerization. But in condensation polymer, byproducts such as ammonia, water, and HCl are formed. That is the elimination of small molecule. Addition of monomers results in polymers. Condensation of monomers results in polymers. The molecular weight of the resultant polymer is a multiple of monomers molecular weight because it is simple addition. Monomer weight result polymer is not a multiple of monomers molecular weight. Lewis acid or bases radical initiators are catalyst in addition polymerization, catalyst in condensation polymerization, and catalyst in condensation reaction. Common example for addition polymerization: polyethylene, PVC, Teflon, CF2. These all are the examples for addition polymerization. Common example for condensation polymerization are nylon, bakelite, silicon, etc. It is all about addition polymerization and condensation polymerization. And simple and example for addition polymerization is ABS, acrylonitrile butadiene styrene. These three unit: acrylonitrile CH2CH CN, butadiene CH2CH2, and styrene CH2CH benzene ring. If these three monomeric unit, acrylonitrile is aging resistant, heat resistant, and chemical resistant properties. Butadiene is high impact strength, low temperature, and styrene contain mobility and rigidity. If you mix these three material together, we get a resulting polymeric material or resulting polymer with improved properties. That is the advantage of the addition polymerization reaction. And this ABS undergo polymerization, or acrylonitrile, butadiene, and styrene undergo polymerization. We get ABS, a polymer with a high impact resistance and toughness, high tensile strength and stiffness, excellent high and low temperature performance, tough, hard and rigid, easy to play and glue, relatively low cost. That's why we get large number of application in ABS, cars, electronics, and building materials. In automobile industry, automobile dashboard, body outer panel, inner decorating plate, steering wheel, sound insulation board, electrical appliance, chains of refrigerators, TV sets, washing machines, air conditioner, computer and copy machine, and all the cabinets we can made up of this ABS and melting blocks, that is toys. An examples for application, different applications of this styrene, butadiene, API, acrylonitrile, butadiene, styrene, copolymer. That is all about